Testing. 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 All right, that seems like it works. Works well. Alrighty, welcome to another Hoopo stream. Today we're going back into the Kaggle Challenge, Scroll Prize, chasing that $1 million dream. So, what were we doing? So yesterday we created some models, ConvNet, 3D ConvNet. And I also made a script that basically sweeps over different hyperparameter values for that model. Things such as batch size, learning rate, number of epochs, the patch sizes, the resize ratios, training dataset size, validation dataset size. So I ran this sweep last night. See here, this is the tensor board. Shows you different runs. Each of these lines represents a model, a neural network that was trained, and how they get better over time, right? The higher, this is the loss, so it starts here and then it gets here. So these are all learning. See how some of them take a very short amount of time. Some of them take a very long amount of time. So these plots can be misleading because basically this is the loss, right? And the loss, even though it shows you within a model whether one model is good or it's learning, and like comparing the losses of different models trained on different hyperparameters is no good. So you actually have to go through the predicted images at the end. So at the very end of all this training, the way our training loop worked, it would run this model and try to predict ink on the evaluation data set. And we got some. So you can see here, this is what some of the better models got. You see, starting to see the beginnings of ink detection. So really, kind of the thing we want to figure out here is what was the hyperparameters. So this is the hyperparameters, right? The name of the folder tells you the hyperparameters that were used here. So we had batch size of 32, learning rate of 0.002, number of epochs 6, patch size of X 512, patch size of Y 32, resize ratio 25, train dataset size, this is the million, and validation dataset size 1000. All right, so the other one, that's this one. Okay. Other one that did well, which is this one, is cover. We have batch size 32, learning rate 0.0006, number of epochs 10, patch size 128, patch size 64. So one thing in common I noticed right there, the patch size X to Y, the ratio of X to Y for the two that did well was almost 2 to 1. Resize ratio 0.5, so again, the 0.5 resize ratio doing well. And this one, trained dataset size 10,000, which is actually kind of surprising. Was able to achieve that with a 10,000 dataset size. And the validation dataset size. Okay. So, with that, go ahead and let's write that down somewhere. So, go to the README, sweeping. say sweep 1 results. And let's put the date for that sweep. So the date for that was 03/27/23. And what did we learn? We learned batch size 32. Make this code's batch size 32 was what performed best. Learning rate. So this best results. But one way to think about what I'm writing down here is if I had a gun to my head and I had to pick only one hyperparameter setting to run, what would I use? Rate of 0.04. I would use a patch size X of 64. Patch size or 128. I would use a patch size Y of 64. Or optionally, the other one that actually did well was 512/32. So these like long vertical boxes are well. Resize ratio, both of them were 0.5. Train data set size. You had, of course, the 1 million. 1, 1, 2, 3, 1, 2, 3. And then we also had the 10, 1, 2, 3. 10,000 and 1 million. Valid data set size 1,000. Actually, this one was on the resize ratio of 0.25. 0.5, 0.25. And this is actually okay. So that gives us a little bit better of an idea of the hyperparameters that are resulting in the best model. So next thing we're going to do is we're literally going to delete all the results because we don't need them, and it's just a bunch of extra crap that we don't need. So that. Now, let's that Kaggle open. And the next thing I wanted to show you guys is what I think we should focus on today, which is GPU memory, CPU utilization, GPU utilization, basically just optimization. So the problem here is we submitted a notebook to the challenge, right? And if you remember, if you go to the code requirements, you basically need to submit a notebook that runs in less than 9 hours. So the problem with the notebook that we submitted yesterday is that it timed out. Basically, it took longer than 9 hours, and because of that, it failed. So we need to figure out, we're going to have to find, use a timer or some kind of like basically logic, some code that will make sure that this runs and completes in less than 9 hours. So I think what we're going to end up doing is we're going to end up creating a training loop that keeps going until there's roughly 8 hours left, and then it'll stop the training loop and it'll give it a good hour to complete the evaluation. So in that way, it'll guarantee it'll only run 9 hours, which is great. I think that this is actually, like, the more I think about it, this is the reason why this challenge is even possible to win, right? Normally on these Kaggle challenges, there's no such thing as like kind of, they're usually not code competitions, right? Usually the way it works is basically whoever gets the best results on the test data set wins. And then what ends up happening is whoever has the most GPUs basically trains the biggest possible model for the biggest amount of time. And it's very difficult to compete against people who have like a 100 cluster, right? But this competition is unique in that everyone is limited to the same hardware. Everyone is limited to a GPU notebook on Kaggle that runs in less than 9 hours. So it's more about how can you squeeze the most juice out of this 9 hours of GPU notebook than it is about how much GPUs do you have available in your house. So really the way to win this competition is find the biggest possible model that you can train for the longest amount of time that fits on a single one of these notebooks. That's actually kind of a different type of challenge than designing a really good model, right? It's actually almost more of a hardware optimization and utilization challenge. What we're going to be kind of focusing on today, we're going to try to see what we can do there. Go ahead and let's save results. And bring this up here. Let's open up a new notebook. Actually probably copy this. Copy our simple net. And we're going to call it 04 dot max. Right? And this is going to be all about finding the biggest possible version of this that we can fit on this machine. So we have our RLE, we have our loading of images, our data set, have our really where we want to add the extra. See, we started to do this here, but we basically need to do a better version of this. So for blank in range what do we want to do? Manually or we're going to create the model. We're going to put the model on the GPU. We're going to make an empty array with a certain batch size, slice depth, patch size. Let's go ahead and make a new node. There we go. Why don't we max 0.04 max GPU net. Copy our generic boilerplate here. Copy the imports. Let's try this P100. And it's going to be Python. That's fine. And persistence. No persistence. Okay. Then let's copy our code. Copy our network. Simple net. Copy our utilities. And let's copy our data set. And then add some code here where we're going to do this process here to figure out exactly how much we have. So let's hit run all. It'll go ahead, it'll start making a session here. Starting. You can see here at the top, they show you how much 5 hours quota remaining. How much CPU, how much RAM, how much GPU. So make this into a. So we're going to do 1,000 fake batches. Each test batch is going to be of batch size, slice depth, patch size, and patch size Y. Try the one from hyperparameter suite, and we did 128 by 64. Batch size 32. Work 1, 2. Epochs 6. Let's create that, move it, and then we'll delete batch, or no, let's just leave it like that. All right, and we run this. So we're running this and we're looking at this GPU here. Should be changing. But it is not. Oh, here we go, 7%, 10%. I see these as a plot. Session metrics. Know what we change the logging. Make the logging right now I can't even. Much cheaper. Change these logs. Or let's actually look it up. Why is my Kaggle notebook not showing logging? Logs not. I had to reset the basic logger. Add the following lines. See if actually print works. Print works, then we don't. GPU, that's what I wanted to hear. Still really only using 2.5 gigs of GPU memory. So way big. Sure. Can my email XYZ. Okay, so I think what we want is, let's try the bigger batch size here. Let's do 512 by, try that. That should increase the amount of GPU. Run that. Okay, now we're using more of the GPU. Actually do test batch dot device. I feel like we can push this batch size of 6. Why is this GPU memory not even? Add some model. Also test batch. Should change this. I don't know. Sometimes these session like logs are just actually. Try an even bigger. Let's batch size of 128, double the batch size. I feel like this should spike the memory. Still nothing. That's the internet. Better, let's add ChatGPT. Give me some Python code that will print out the new memory used and available Kaggle Kaggle notebook. I don't want that. Print out the GPU memory used and available in a Kaggle notebook. You can use NVIDIA SMI command line utility Kaggle notebook. map it. Kind of like a overly complicated way to do it, but all right. Copy that in there. This. Run this. New memory used 591, memory available 689. That is correct. That's matching what we have here. Let's actually having this. And make sure. All right, that's do it before the model, but after the model. Print not assigning it to the right device. The this is no good. Not Kaggle PyTorch working. Would have worked if you're trying to start the. Run, start. All right, here we go. Okay, so it was using the GPU. It just, because we weren't deleting these, it wasn't removing them. So we're seeing 2 megabytes without. So this is basically nothing. You have the 16 gigs that are available in a P100. Then that's the first one. The second one is after we load the model. So the model itself is actually tiny, 115 megabytes. Right, we can definitely make that bigger. Oh, let's do 10. I don't know if I want to make that bigger. I almost want to just make the batch size. Yeah, let's leave that at 512 by 64. Maybe let's do 512 by 1. You give me code to call memory in PyTorch. You can delete the objects. Did. Working before. Clear GPU dash g collect. Part that I need. Here. We'll say model equals none. Test batch none. So basically references that, and then we'll hash and then collect. So if we run this again, let's do 10 batches. GC is not defined. We need to import garbage. Import sob process. Import. Let's add more. Or start. Loaded model. Batch. I. You see now we're using a little bit more. About 3. Go ahead and run that again. Have start GPU 8 megs, 100 megs out of model is. Try uneven batch size. Let's batch size here. All right, now we're talking. Now we're at 5 gigs. Definitely do 512 batch size. All right, we're basically at 10. Make this patch size a little bit bigger. Like I just want batch size. Let's yeah, batch size of 8. So the way I'm thinking about this, I almost want a small model. I want to overfit the smaller model than underfitting the bigger model. If that makes sense. I'd almost rather try. Okay, so now we're getting the memory out of error. So I feel like this is the spot here. 512 by 128, batch size of. Model is about 600 megs. And once you load the batches of data, you're at roughly 10. Why it's because why does it grow from? I think it's because there's maybe normalizations or regularizations in our model. Could that possibly be it? This is a lot better. I'm liking this a lot more. Okay. So figured out a good setting of batch size and patch size for really make use of the GPU. So another thing we want to do is we want to add code that tests time. So for time. Can you write Python code for me that uses the time module? Take note of the start time for a Jupyter note. Then I want it to check the total elapsed time, and once it gets to 8 hours, I want it to break from a 4. Time applies a variable for elapsed time. These here, top. Get rid of these of logging. Have notebook will only run for this amount of time. Lapse time, train time. max train time. Do this time start, time lapse max, time eval max. I don't think you need the eval actually. Time train max, we want 8 hours. And okay. Let's add this. So we added this GPU memory. Let's also add clear memory. Dot is by that we're select and add there. Emptying memory. Let's go ahead and up here. Back down. Copy abilities. Device. Clear. Why don't we also crash this? Go into our max GPU net. Let's go ahead and copy all this new we have here. Let's get rid of the logs. Rinse. Our classification data set. Let's f log. That in. Replace log debug with print. That one. And let's also replace log info. All right, and now let's go into our training loop. Let's get these numbers in there. We have 65 slices of 512 by 128, resize ratio of 0.25, batch size of 600, num workers of 1, learning rate of 0.0002. Yeah, that seems fine. Number of epochs 6, and threshold of 0.5. Don't need this code, but you know what? We might as well just copy it and paste it here. Then let's copy that. Now we're actually in the training code. And in the training code, we have our data set, our sampler. Actually, I want to loaded data set. We have the data loader, we have the optimizer and binary cross entry loss. Then we're going here and we're creating all of our torch data loader and we're stepping. So here we put the patch and the label to training on batch. Let's do I patch in rate VM data loader. This will I. Okay, then once we delete the data loaders, then we're gonna do our clear GPU memory here. Create our submit path. This is also where we should check for this. So right here, if so let's read that elapsed time elapsed equal to time.time minus time start. If time elapsed is greater than time train max, print say time limit reached, stopping training, and break. This will make sure that break out of batches and also break out of stopping training, stopping batch, stopping so let's go ahead and copy this to our notebook. Up to the top, copy, paste, paste, Paste. Have all our code in here. We're going to restart and clear the cell outputs. Rerun all of this. Data directory Kaggle input Vesuvius challenge into not exist. Ugh. Problem is that this isn't a submission notebook challenge. Random notebook. Oh. Net off. Save this. Save this. Maybe if I go to this one. Code. New notebook. Guess we're gonna have to copy paste again. Accelerator. E100. No internet. And Python. Copy paste stuff again. This. That. That. Save this. Save version 1. Save. Let's hit run all. Let's make sure. This automatically count as, or is it just running for the stop this? Stop. Canceling. Back to the prediction. Simple net. Select notebook. Kaggle shift. 04 max. Save this. Save and you want to doesn't even correctly. God, this is Kaggle. Why is this so shit? Version has been saved. Is it available now if I hit here? You have 5 submissions. We have this notebook. And save it. Save. Never save output. Run without an accelerator for this session. If I hit submit, stop. I think you just need to hit submit directly from here. So I guess what I'm save and run all complete. Okay. Notebook cannot use internet access. Please disable the internet. This Kaggle interface is so bad. Why does it need to run the notebook to save it? You need to run the entire notebook to commit it? Doesn't make any sense. And why does it tell me? Why isn't the name updated, first of all? Second of all, why can't I submit this when this is already internet off? It's atrociously. My work. Code. No attached out of all of this. Maybe having multiple open is. So I don't care about this one. this one here. Actually kill it as well. Back to my work, back to my code. This notebook here. Edit this notebook. Notebook was configured with the accelerator was re-enable the GPU. We're gonna call this 04 max net. Internet off. D100. Let's submit. Add. Why does the Kaggle notebook run before I? Most people participated choose to use a notebook to train and another notebook to test and submit the result. Training notebook can save the training model state, and the test notebook can use it by add data and then test the data. Here it's training. Runtime error. Data loader exited unexpectedly. Version 5 failed to run. Your notebook tried to allocate more memory than is megs after the model 6 megs. Loads the 65 slice image. Dataset is loaded, still hasn't impacted. I think the update set. I just want this to run. I just want this to run without errors. Why is this so hard? $256 by 64. Batch size of 2. Now it's way smaller. Should work fine. Let's just do 2 epochs. Random sampler of trained dataset. I'm gonna actually a total dataset size, and we're gonna do a main dataset size. We're gonna set this to 10,000. And we're gonna come here. We're going to limit the size of our train and our valid. Size. And we're going to shuffle these indices. Then we're going to only select the first 10,000 of those. Print. And we're not going to use a random subset. Okay, so now we're going to be training on a smaller data set, But also I realized another thing we're going to have to do here is the resize ratio for the evaluation has to be 1. It's going to be 0.5 just because. But then we need to take this predicted image. And write Python code need to size a NumPy array larger size. Want to sing news. Can you do it without SciPy? So I don't like how this notebook isn't even the right name. Just 0.5 or trying to write Python code for me to size a NumPy I want you to style image. So this prediction image here is the size of the evaluation data set, which is coming at this size ratio. But I want to just save. You don't want to have to do get original image. original image size X and original image size Y. Here. Val. Can you resize the numpy array with just numpy as the dependency? Sure. You can use numpy's nd array method to create an empty output array and then interpolate the values from the array. I want. What? This is just a better way to do this would red image dot from array image dot resize X Y by cubic red image should equal np dot array back up our code. We have self size dot original size image Y. That's what we want. Okay. We're going to go to the competition. Use challenge. That's not how we got to it. We got to here. Your profile. Code. This one here. Edit it. Call it 05. Trying again. All right. Save version 6. Save all and commit. Have while this runs, go ahead and try to run this on our computer. Python environment, that should be. Directory does not exist. Data-train1 and copy the out. Data-train1 and then data dash that. Thousand. Data directory data-train-1 not exist. We probably do path here. Home trend dev dash and data train let's put that. Run this. All right, we're getting it. Output probably failed because it data set size. Oh, this is sensor. These must be long in byte or bool sensors. Get rid of this weird crap that we. Right, we're training. Data set. Training. Kernel crashed. For all outputs, I think the GPU on this computer is small batch size here. By batch size of start. Loading the 5 slices. Starting the task index. Not liking this. Subset random of text. Do we actually also know raw dataset size 1,830,000? Model torch has no attribute. Good. Run it. Or 6 slices. Clock 1 of 6. On batch. Roughly about half of the memory. This is going. So this all right, epoch 2. Let's actually interrupt this. Make the data set even smaller and the number of epochs less. I want to basically run notebook. 256 by 64. Make the batch size a little bit bigger. 512. A Kaggle increase People complaining about GPU quota. Now this is evaluation. Okay, you see quota, accelerator quota. Can I like get more of that? Like pay, get more quota? Is that a thing? Code. This is successfully running. Currently evaluating. Here or submit. Simple net. Back to the create a new notebook. Five. Try. $100. Save this by draft save. Copy paste all of our crap again. Save. Vesuvius version 1, notebook 5, try again. What I want. Okay, hit submit. Okay. Perfect. So now this is running. Should finish relatively quickly. Because this is just like a tiny data set. We made it like a 1000 data set, small batch. Okay. See what you get there. Look at that. It made. Gonna take 30 minutes to evaluate. What? While that's going, let's think about what the next sweep. Have our choice of slice depth, workers, our batch size. Oh no, notebook through exception. Happened. What happened? Oh. In the wrong path. Edit. Also make this 1000. Save version. Actually, notebook try again version. Okay, batch size 32 for both the winning submissions. Let's try 32 again. We'll just set 30. Learning rates, both of them were relatively small, so let's narrow the learning rate sweep. Num epochs, only 6. Right? Let's do 6 then. Let's just do 6. Patch size X, this is the interesting. I'm going to do 128 and 512. And then patch size Y, we're going to do 64 and 128. Resize ratio, both of them were 0.25 and 0.5. Let's get rid of the tiny one. And dataset size, valid dataset size, let's make it 1000. And we'll try the train dataset size again. Because, for example, one thing that I noticed over the night, right, randomly happened to pick one that was 512 by 512. And it data memory. So I think the biggest one we want to be able to do 512 by 128. Then another thing I really want to test here, I want to start model. We're going to have an hp.choice. We're going to have net, have a simple net, and we're going to have net we're going to add a parameter here, model. Inside this model, if model simple net, however, elif simple net norm, we're going to make a different model here. Call it simple net norm. And let's go ahead and that as well. And let's open up our model and create a simple net. Do the same thing, except we're going to add batch norm, layer norm. And you add layer normalization and batch normalization as appropriate to my PyTorch model. I assume you want to add layer normalization to the fully connected layers and batch normalization to the convolution layers. God, this one failed again. What's going on here? Notebook out of memory. That RAM or is that GPU? Sounds like it's actually GPU or the RAM, not GPU. In order to fix that, we can actually the resize ratio 5. Means we're probably going to have to reduce the size of the or by profile, code, try again, this edit, out, change the ratio to 0.5, patch size we'll say 4, patch size Y we'll say, let's do a little square kernel. Size patch size. This is like the smallest. It's tiny at this point. I feel like this has to work. Submit this. Version 3. Submit. Alright, and let's go ahead and do it. Go back to our actual code here, which means back to this. Alright. I added batch normalization layers BN1 and BN2 after each convolution layer. So here. And then 1. And layer normalization layers L1, LN1 and LN2 after each full connected layer. Except for the last one. I don't think this batch norm before max pool makes any sense. Should there be a batch normalization for a max pool? Okay, max pooling, downsampling. Apply batch normalization before max pooling because batch normalization can help in achieving a more stable or reducing the spatial. What about batch normalization at the very start network? Yeah, so the problem is if you get a batch that's all a bunch of zeros, then it'll normalize that batch. So I think this is right. It's probably, you don't want to batch normal, but I don't know, our batch size is so big at like 128 that maybe batch norm is fine. Hard to say. I think let's just try this. Okay. We're gonna have to add the model. Model is that that's form. Right. See if our Kaggle out again. Profile. Code. Competitions. Use challenge. Missions. Running. Logs are. Loaded all the images. Okay, that's good. This is where it could potentially error out though, because you try to allocate too much memory. Add model. Model. Let's Another thing I potentially wanted to do is train on the different data sets. It might be the case that training on all three data sets will result in better things, but it could also be the case that training on only one of them will be better. There might be some that are noisy and some that are not noisy. So we could change this to errors. This actually want to also test optimize. Let's do that. add that very well. Optimizer. 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 Atom. Change the render is just dash. Then we're going to have a new hyperparameter, which we call curriculum. This one is going to be a choice two. One, three. Make these string. 1, 3. Have 1. Type this through well. Model. So pass in. We defines order of 4. Current dataset ID in render put a training on data. That'll train on that. Need to create training and validation. No, I'm starting to think that the validation is actually. I think we're gaining any. validation. Total data set size. Shuffle. Train. There. Crap. Train clear, train data loader. Test for loss. Loss. Less than best loss. Best loss equal to train loss. Model. Slow us down and then that also we can go back to the size. We can see where we're at. Logs. Successfully ran. All right, perfect. What did we get? What might have even gotten a worse score than what we had? Let's see. Your profile, competitions, Vesuvius challenge, submissions. 0.12. Where are we at? 30. Oh, yeah. Oh, look at that. We're making it to the top, guys. We're making it to the top. Team name. Famous people from Pompeii. Lucius Eucundus. Save changes. Now that we have this running, go to this, edit it, and let's put a little bit stronger. let's do dataset size 100,000. Num epochs 8. And resize ratio 1. And let's do patch size 28 by 64. And let's submit. So bigger data set, longer number of epochs, slightly larger patch sizes. Okay. Okay, so back to what we were doing here. We added these extra parameters, Atom versus SGD, SimpleNet versus SimpleNet norm, curriculum. So in order to test this, we're going to need to basically make these. So let's say if args dot seed -1 or equals 420 test mode, so say test mode, a search space train dataset size equals 100, search space num epochs equals 2, search space slice depth 2, search space size ratio or equal 0.05. Okay, so now try to run this. Here our output directory. Interrupt this. Output. Let's try have a right here. All right, Python sweep seed 420. We want to see if we can run it without mistakes. Okay, here we go. Local variable train IDX referenced before assignment. 980 loop. Length of train dataset. Run it again. Okay, seems to be working. In the meantime, we're going to go do a little bit of push-ups, a little bit of squats, and then we will come back. We're going to let this run and make sure that it gets through all of them. All right. Gotta make sure to do some exercise, you know? Can't be sitting at the computer too long, especially at my age, because my back starts hurting if I do it. All right, I mean, this looks like it's running fine. Let's look at our tensor board. All right, let's let it run a tiny bit longer. I just want to see it do all the hyperparameter values. Double check. Python. Or INA. Okay, so here there's going to be an issue, right? Because there's going to be other epochs. We want there. Because right the way it is now, it's overwriting. That. And rerun it. See if our Kaggle fails. Still going. Okay, good. Good. Here we go. Curriculum 1, 2, 3. Training on 1. Training on 2. On 3. Then evaluating. That in our Jupyter sensor board. See that and look at that. Loss does go down. Perfect. I think this is ready to go. I think we can go ahead and run this and see what we get tomorrow. So in the meantime, let's log all of this. Save, not log, sorry, commit all of this. Say ready. Sweep. We're going to commit all of this. Let's make sure that the sweep that we're going to run is exactly what we want. Dataset sizes, resize ratios, patch size, num epochs. Do a little bit more here. Let's. Yeah, 6 is fine. Kernel. Yeah, I think this should be fine. Maximum evals, let's do 100. We're going to run this. Actually, out. You know what? I changed my mind. Let's not do 0.5. Let's only do a 0.25 reset. And I'm going to run this, but as soon as I run this, my camera and microphone are going to start dying because all the CPU is going to get used. So I'm going to end this stream here. Hope you guys found that useful. We're making progress here. We're already at number 30 on the leaderboard. So we will keep making progress, and then hopefully we can get into the top 10. I think prize contenders. So we need to get above a 0.49 in order to get in here. Cool. Thanks for listening, and see you guys later.